So next up, uh, we have the pleasure of welcoming Simon Ritter, Deputy CTO at Azul, one of our strategic members of the Adoptium Working Group. He's joining from UK. And today, Simon will take us on a journey titled 30 Years of Java, How Did We Get Here? He'll revisit Java's evolution, highlighting key milestones and sharing unique insights from someone who's been part of the story from the very beginning. So over to you, Simon.
Okay, thank you very much. Right, let me just share my screen. Right, can you see my slides? I'll assume that's a yes. Okay, so yeah, I'm actually not joining you from the UK today. I'm actually in Colorado at the Dev to Next conference that's being run here. So yes, the idea behind this presentation is to look at the history of Java, 30 years of Java that we have. And how did we get here? Just a little bit of background about myself to sort of understand why I can talk about this. I joined Sun Microsystems way back in February of 1996, basically about the time that JDK 1.0 was released. And although I wasn't hired to do Java at the time, I quickly saw that Java was going to be something that I thought was going to be pretty big, which is good because it was. And I decided that I would move into a role that would allow me to do things with Java. And so I started doing Java, and I followed that all the way through the Sun years until we got acquired by Oracle. And then I spent another 5 years at Oracle. And for the last very nearly 10 years, I've been at Azul doing Java all the way through that. So the first thing I want to show you is this, which is the slide from the very first presentation I did on Java. This goes back to early 1997. So obviously my email address is wrong. You can't reach me at that email address anymore because, well, Sun doesn't exist anymore. And when I tried to load this presentation into PowerPoint, because I'm a sad individual and I keep all these sorts of things for 30 years, I found that I couldn't load it into PowerPoint because it was too old. So I ended up having to use OpenOffice, loading it into that and then exporting it as a more modern PowerPoint so that I could get it into my presentation. Anyway, let's start with a little bit of prehistory. How did we get to Java? So there were a lot of design influences that led to Java. Java was an interesting platform when it came out, but it didn't actually really have that many new ideas in it. It was more about bringing existing ideas together in a way that allowed you to do things in a slightly different way. So let's explore some of those influences. The first of those goes a long way back, right back to 1962. And this is the Lisp programming language, which is a much more functional style of programming language. And the reason this is significant is because it was the first language that used some form of garbage collection. It wasn't really garbage collection in the sense that we think about it, but it was more sort of automated memory management and meant that there was some behind the scenes management of memory so that you didn't have to do all the work yourself manually. The other thing that it had, which was the first sort of idea that we saw this being applied, was just-in-time compilation. Now, it wasn't called just-in-time compilation back then, it was called compile and go. Because you have to remember that in 1962, most computers were being programmed using punched cards. I'm sure there's not many people in the audience today that actually can remember punched cards. I sadly am old enough that I can remember punched cards. But the idea was that you would actually generate punch cards from the program and it would sort of recompile it as it went along. The next thing that we need to look at is a programming language called Simula67, so 1967. And this was notable because it was the first object-oriented programming language. Java, as we know, is object-oriented. It has the concepts of encapsulation, it has inheritance, it has polymorphism. And so all of those things came from Simula67 as a programming language. The other thing that's notable about this is it was the first programming language that James Gosling learned to use. So clearly it had influence on him when he was developing Java. Then we move forward to 1973 and we have the C programming language. Now this was part of the Unix side of things, the AT&T, all of that sort of operating system kind of thing. The reason this is significant is because when Java was created, C was a very popular programming language. What James wanted to do was to make it easy for people who knew how to program in C to migrate to using Java. So he lifted a lot of the syntax directly from C and applied it to Java. If you think about the way we use braces, if you think about the way we use for loops and while loops and those types of things, and even the switch statement, and that's taken directly from C with the idea of fall through and so on. So the syntax of Java is very, very heavily based on the C programming language. Then in 1978, we got Pascal, which was really the first idea of a virtual machine. And this was where the compiler that you used for the Pascal code wouldn't generate native instructions for a particular platform. It would generate P code. P code was a sort of halfway between source code and machine instructions, part of the compiler phase. And what that would do is it would then be passed to this virtual machine, which would take those instructions and convert them on the fly to the native instructions for the platform. Obviously, that's the way the virtual machine works. So that's, again, a strong influence. And then the last thing we need to look at was the idea of the World Wide Web, which started back in 1991. And this led to the creation of the Mosaic browser, 1993. And maybe some of you in the audience will remember the Netscape Navigator browser, which was in 1994. And that was significant because, of course, as we'll see, the whole idea behind Java initially was around adding functionality to web pages. Okay, so the pieces are all in place. We've got all these different technologies, but where did Java itself actually originate from? It didn't just spring into existence. Where did it come from? The answer to that, we can go back to 1991. And Sun Microsystems was a very successful company at that time. And the people who worked there had been there for quite a long time. And they'd noticed, some of them had noticed, that the company was becoming more commercial in its approach, which is very logical as a company grows. But they were kind of keen to go back to some of the roots of the company, because you have to think that Sun actually stands for the Stanford University Network. They wanted to go back to the roots of the company in terms of the idea of doing more research and looking at what was going to be the future of computing. And so some people wrote a letter to Scott McNealy, who was the CEO at the time, and they said, look, we really need to take the company in the next direction and figure out what things are going to happen. And he came back and he said, maybe you guys are onto something. Why don't you go hide away somewhere and think about what it is? And so a group of people did that. And as you can see, some of the sort of founding members of this group, Ed Frank, Patrick Norton, Mike Sheridan, and James Gosling. So they went off and they decided to look at what was going to be the next big thing. Now, rather than basing themselves in Sun offices, they decided that to really do this properly, they wanted to get away from Sun and actually just isolate themselves and look at what they could do in whatever direction they wanted to go. So when they started this project, they found an office above the Bank of America in Menlo Park, and they decided that they had to have a name for this project. They called it Project Green. Why did they call it Project Green? Well, as we all know, the two biggest problems in computer science are cache invalidation and naming things. So the way that they decided to name their project was they looked around and they saw that the door to the office was green. So they called it Project Green. Now, the idea behind that was to look at what the future held in terms of IT. And so part of that, James Gosling sat down and he started looking at programmability for a particular project they were working on. Initially, he started with C++, and he decided he'd make a few changes to that. But eventually, he decided that there were so many changes he was making to C++ that he would actually create a separate programming language. Rather than calling it C++, he'd actually call it something else. So once again, we have the naming scheme problem. And he looked around and looked out of his office, and there, outside of his office, was an oak tree. So it became Oak. Oak was going to be the programming language that he worked on. And in terms of the description of that, he came up with this kind of one-liner about what Oak was going to be. A simple, object-oriented, distributed, interpreted, robust, secure, architectural neutral, high-performance, multi-threaded, dynamic language. He should have been in marketing, shouldn't he? Because that's all the buzzwords of the time in one particular thing. Now, if you look at that, it actually does describe very carefully what Oak is actually about, because the idea was to have a distributed programming language. You could move code around a network. And if you wanted to do that, you had to have architecture neutral. had to be able to move to different platforms without having to be recompiled. That means you have to have it interpreted, the idea of changing the code into the native instructions on the fly. It had to be high performance, it had to be multi-threaded, it was object-oriented because of Simula 67 and so on. It really was all of these things. So the idea behind this was a device which the green team came up with, and this was called the Star 7. Once again, why was it called Star 7? Well, it turns out that, again, naming problems, they looked around and they decided that the code that you had to type in on a phone in the office to answer an extension was Star 7. So that's why they called it the Star 7. Now, what this device was really a very early incarnation of the iPad. So it was a device which had a screen, you could interact with the screen, there was no keyboard, as you can see, and it was designed to be a sort of remote control on steroids. And if you go on YouTube, there's actually a video, which funny enough, I watched yesterday, which shows James Gosling demonstrating this. And so I put a kind of screen grab that you can see on the top right-hand corner there. And it's really, really impressive what they did with this. When you consider this was 1992, so it was over 30 years ago, and you can look at the left-hand side there and see the specification of what this device had. So it used a microspark chipset. Sun had developed the Spark architecture, and so they used the readily available architecture that they had in the company. It had 4 megabytes of RAM, megabytes, not gigabytes. So that's a really small amount of memory. It had a radio link, which ran at a very sedate 200 kilobits per second. As you can see, it had a TV screen that came from a Sharp TV, had a touch screen that didn't allow multi-touch, but it was, usable, and a couple of other things in terms of PCMCIA and an IR link. And again, if you watch the video, you can see that it's really impressive, the user interface that they came up with in terms of allowing this device to work. So they decided this was what they wanted to do. And part of that was the idea of having an agent, something that could help you on the screen. It was a sort of, again, before Clippy came out, if you remember Clippy from Microsoft. And the idea was that if you needed help with a particular task, you could click on this agent and he would help you through the task that you wanted to do. Now, as we can see, this is a familiar character for us. First of all, he was called the agent. Then they decided to call him Fang. I think that's a bit unfair because they said he looked a bit like a tooth. I don't think that's really fair. So eventually he became, as we know, Duke. So we have a logo and we have an icon for the platform that they were building. And this even led to him having a single episode of his own comic. I've actually got a copy of this myself. Again, if you Google this on the internet, you can find people have scanned it and you can read the comic if you want. Before Duke, they came up with this guy who was called Greenbot. I definitely don't think he was as good. I like Duke. Duke is a good mascot for the platform. So in 1992, one of the things they did was they actually spun this team off, the Green Project, into a separate company. They called it First Person Incorporated. And again, you can go on the web and you can download the specification for the Oak programming language. It's actually quite different in some ways to Java. You'll find it very familiar, but there are a few things, especially in some of the keywords that they had, which are quite different to what Java became and what we know now. So it's worth having a look at that just as a historical context. One other thing that happened in 1992 was that the team had put forward a proposal to Time Warner, who made set-top boxes for TVs in the US. And they put forward a proposal for incorporating the technology they developed for the Star 7 and Oak and so on. And that had not been successful. Sadly, hadn't been selected. And so some members of the team had decided that they weren't really getting where they wanted to go, and they returned to Sun to work on the more familiar technology that they had been working on before. But the core part of the team stuck together and continued working on the project. And then in 1994, this is where the kind of real pivotal moment happened for Java. James Gosling was sitting in his office and John Gage popped his head in. John Gage was the chief scientist at Sun at the time. And he popped his head in and said, James, can I borrow an Ethernet cable? James said, yes, you can borrow an Ethernet cable, but what do you want it for? And John said, well, I'm going to go and do a talk at TED, which was a conference being run in Monterey, of course, back in 1994, nowhere near as famous and as popular as it is now. But he said he was going to go and do this talk about some of the things that the Project Green had been working on, specifically the browser technology that they'd been working on. And the browser was called WebRunner. Once again, in terms of naming, the team had been very keen on the Blade Runner film, so they decided that they would call it WebRunner, based on the Mosaic browser, but with extra things that they built on top of that. So James said, yep, okay, if you're going to demonstrate this, I'm going to go with you to make sure everything works. So they went down to Monterey, set everything up, and John Gage started doing his presentation to the TED audience. He presented this web browser. Now, web browsers had been around for a little while, and people looked at that and they were like, no, it's another web browser, whatever, it's not very exciting. But one of the things that had on the screen was a molecule. You can see the molecule there in the bottom right-hand corner. Fine, had a picture of a molecule. But then John clicked on it with the mouse and started dragging it around and pulling it apart and putting it back together again. Suddenly, we had interaction with the web page, and everybody was like blown away. Suddenly, it was like, wow, this is really big. If we can add interactivity to web pages rather than just static information, this opens up a whole new set of possibilities for what we can do with the web. So in 1995, Java itself was launched. Now, obviously, we had Green and Oak, but the reason they couldn't call it Oak was there was a trademark had already been registered, so they decided they had to find a different name for it, and they looked around and they decided on Java. And I think that was probably a pretty good idea. Interestingly, when they made the launch of this, it was much more about pushing the idea of the hot Java browser, because that was the thing they really wanted to make the thing that was the highlight of this launch. And one of the things that they also did was they managed to do a deal with the Netscape company, so Mark Andreessen and co, and agree to have the Java programming language included in Netscape Navigator 2. And that was really good because obviously that was the most popular browser at the time. So having hot Java browser and Netscape Navigator support Java meant that more people would be able to use it, and therefore it would be more popular and adopted more quickly. And they came up with this slogan, write once, run anywhere, or as a lot of people refer to it, write once, test everywhere. I'll put a list of names here. So Silk, DNA, Lyric, Pepper, NetProse, Neon, Ruby, WebRunner, WebDancer, WebSpinner. All of those were possible names for Java when it had to be changed. So we could be sitting here celebrating 30 years of Pepper or 30 years of Ruby. Hang on, there is a Ruby. Anyway, so Java was launched. And so what happened next? Well, Java became very popular. Lots of people looked at it and they thought, yes, this is going to be the next big thing. Enabling applications to run in a web browser is going to open up all these new possibilities. What Sun did next was to create a new division within Sun called JavaSoft. And they were all tasked with the idea of making Java a success and looking at ways that Java could be applied to all sorts of different things, not just web browsers. And what they came up with was various ideas. They came up with the Java operating system. It was written entirely in Java. Didn't really take off very much, so they kind of abandoned that. They also created this thing called the Java Station, because again, back in 1996, you have to remember that some people were still using dumb terminals. And the idea behind the Java Station was to give you a terminal. You could access mini computers and mainframes, but do it in a much more intelligent and smart way. You could have more capabilities running on the terminal. So it became the Java Station. And there were a couple of versions of this. One was called the Mr. Coffee, and that was really just a rebadged Spark station. It was just a rectangular box. I had one of those, but I never managed to get hold of one of the Krups. These were much nicer looking. You can see the picture there, had more sort of curves and certainly looked like a much more interesting computer than a square box. The problem with this was it was very limited in terms of resources. It had only 8 megabytes of RAM. Now, although the Star 7 was designed to work with 4 megabytes of RAM, when they put an operating system on the Java Station, then they put the Java virtual machine on there, and then you put applications. 8 megabytes really wasn't enough. And I remember trying to run things on this, and it was very, very slow. Really wasn't something that you could use on a day-to-day basis. So the idea is that kind of took off and then just got abandoned. There was supposed to be a third version called the Super Java Station, but it never saw the light of day. The other thing that happened in 1996 was Microsoft kind of caught up with the idea of the internet. And so they had the Internet Explorer. And they then decided with Internet Explorer 3 that they would include Java in that. So that was great because now we had Java across all the major browsers. And that meant that we could write applications, put them onto web pages, and then whoever was using whichever web browser would have access to them. This is great. This is how we want things to be. Unfortunately, that didn't really last. So in 1997, here we have a picture of two very happy, smiling people. On the left, we have Scott McNealy, who was the CEO of Sun Microsystems. On the right, we have Steve Ballmer, who I'm not quite sure which role he had. I think he was CTO at Microsoft at the time. And yes, they look very happy, but unfortunately that happiness did not last because in 1997, Sun sued Microsoft over their Java implementation. The reason they did this was because Microsoft had adopted Java, put it into the Internet Explorer. But what they'd then done is said, we think we can improve Java. We think we can add some extra capabilities in terms of the core classes. And some of those core classes we don't really like, so we're going to remove those. Now, that's bad because, of course, we have write once, run anywhere. The idea is you take the same application and it will run in exactly the same way on whichever platform. If you start messing with the standard libraries and adding things and removing things, it means if you write your application in Microsoft Java, you've got these extra libraries which don't exist in Sun Java, and Sun Java has ones that have been removed from Microsoft Java, then you lose that cross-platform functionality. If Microsoft had just left the core class libraries alone, created their own Microsoft extensions in their own namespace, we would have been good, but they didn't. So Microsoft got sued by Sun, and eventually they settled for $1.9 billion. The other thing that happened was in 1998, people started looking at Java and thinking, this is really good, we want to use it, but we want it to be more open. We want less control from Sun and more ability to contribute ideas and make it a more open platform. And so the GNU class path came about. And this was a project started to initially create an open source version of all the class libraries that we have in the Java platform. They called it GNU class path because they couldn't call it Java. Java was trademarked and they couldn't use that. So they used the normal approach that computer scientists use, which is to use a level of indirection. And they said, well, the class path is going to have the word Java in it somewhere. So if we call it class path, then we're sort of indirectly calling it Java. So they started working on that, and then they had a couple of other things, which was GCJ, that was the Java compiler that they wrote, and there was even a sort of rudimentary project to create a virtual machine called Jaffa. In 1999, Sun acknowledged that there needed to be more openness about Java, and so they created a thing called the Java Community Process. There had been calls for Java to be made part of an open standard. Rather than contributing it to an independent standard body like ANSI or the European Computer Manufacturers Association, Sun said, we need to maintain some level of control, so we'll create our own standards body, the Java Community Process. And that's been around, obviously, for 26 years now. The way that works is that other companies outside of Sun at the time and Oracle now can join the JCP, and they can contribute to the design of the specifications. So each version of Java has its own Java specification request, as it's called. And a JSR has three parts to it. The first is the specification itself. In the case of Java, Java language specification, the Java virtual machine specification, and a list of all the class libraries. Then you have a reference implementation, which is an implementation of the specification to prove that the specification can actually be implemented. And the last bit, which is very important, is what's called the TCK, Technology Compatibility Kit. A set of tests that you can use to verify that if you write your own implementation of that specification, that it actually matches the specification. So you have to run TCK to guarantee that what you're creating is functionally equivalent to that specification. So this leads us to a bit of a problematic time in Java's history, from 2005 to 2009. And the reason this was problematic was because there was the GNU class path project had morphed into an Apache Foundation project called Harmony, heavily backed by IBM at the time. and again, looking at building an open source version of Java. So they did a lot of work on that. But the problem they had was, in order to prove that what they had created matched the specification, so it could be used in the write once, run anywhere way, they had to run the TCK on it. And Sun did not want to make the TCK available to the Apache Foundation. This led to several years where the Apache Foundation said, we want the test suite. Sun said, we won't let you have the test suite. And Apache said, okay, if you're going to do that, we are part of the JCP, and we will block all subsequent JSRs for Java versions. And if you look at it, that's why we have a very long gap, was one of the reasons we have a very long gap between JDK 6 and JDK 7. JDK 6 came out at the end of 2006, and JDK 7 didn't come out until 2011, if I remember rightly. So there was a 4.5-year gap between versions. A large part of that was down to the disagreement between Sun and the Apache Foundation, which then leads us to 2006, which is when Sun decided that they would open source their version of Java. And this is where we get the OpenJDK from. The OpenJDK was created as a project, and initially only the hotspot VM and the Java compiler was contributed to that. The reason they didn't open source everything all at once was because they had to be very careful about the rights they had to the intellectual property. Lots of companies, IBM, HP, various other companies, had contributed things to the Java platform. So they needed to make sure if they were going to open source it, they had the rights to actually make that available. 2007, they got to the point where almost all of the code had been open source. There were still a couple of things that required some binary, what are called plugs, to build the JDK. I think it was actually JDK 7, if I remember right, it was build 31 was the first one you could actually build completely from open source. But it was very much that you could look at the source, reference it, and figure out, how things worked. Sadly, in 2010, the reality of the way that Sun was working as a company sort of hit home. And again, as I remember that, we had the dot-com boom at the early 2000s, and then we had the dot-com bust in sort of 2000, 2001. And from then on, really, Sun never recovered. And we sort of just saw a gradual decline in terms of revenue. We tried all sorts of different things. We basically open sourced everything. We tried buying tape companies. We tried doing all sorts of different approaches, but we just were struggling to make money. And eventually that became an issue, and Sun got acquired by Oracle. And so we ended up with Sun Oracle. They didn't use this logo for very long. I think they only put it on some of the Sun hardware they were still manufacturing. And James Gosling created this little picture of Tux and Duke lamenting the end of Sun as a company. I must admit, for me personally, it was very sad, because I really thoroughly enjoyed my time at Sun. So how did that then change things? Well, 2010, 2011, going back to the Apache Harmony project, with Oracle taking over, Oracle made some decisions. And they basically went to the Apache Foundation and they said, look, we are not going to give you the TCK. You have to get to the idea that that's not going to happen. And they had some discussion with IBM as well, because IBM were a big backer of the Harmony project, as I said. And eventually it was decided that Apache would accept that they were never going to get the TCK. So they withdrew from the JCP completely. They said, we're not going to be involved in that anymore. The Apache Harmony project was abandoned, and IBM then switched all of the engineers they had been working on Harmony to working on OpenJDK. So it was very good from that sense. We got a lot of sense of community, and people kind of came together, and we resolved all the problems around that. So that then led to sort of 2011, and with, again, Oracle making some changes. One of the things they decided to do around the way that Java was developed was they would switch away from using these big JSRs, the Java specification requests under the Java community process. Rather than doing everything through that, they said, well, let's sort of make it more fine-grained. Let's make it more part of the OpenJDK process, and we'll have these things called JDK enhancement proposals, or JEPs. And as I'm sure you know, you've seen, there are lots of JEPs, and each version of Java now has a set of JEPs. It doesn't mean that we don't have a JSR. There's still a JSR for each version of Java. It's just that most of the features that are developed, in fact, all of the features that are developed for Java, are done through individual JEPs included in the specific version of Java, And so you can see the specification of that, but that gets rolled up into the JSR. One of the reasons for that really is that the JSR only applies to Java SE. And Java SE as a standard only includes the virtual machine, the language specification, and the core class libraries. Other things in the JDK, other tooling and so on, isn't covered by that. So JEPs cover everything in the JDK, not just stuff that's in the Java SE. This sort of leads forward to 2018 and until current time. And in 2018, we had an announcement from Oracle about moving Java forward faster. And this is where we switch from having feature-based releases to time-based releases. Rather than waiting till all the features were ready for a particular version, they would say every 6 months we're going to release a version of Java. And so March and September, that's what we're seeing. This is what we see now. Now, the other thing that happened was that various things changed around, excuse me, various things changed around licensing for the Oracle JDK. And so we then saw a proliferation of other builds of OpenJDK, so binary distributions. So obviously we've got Temurin from Adoptium, Microsoft have one, Corretto have one from AWS, and Azure Platform Core from Azul. So this all led to, moving Java forward faster. We've seen a much quicker, I think, development of features. I've seen more features added to Java than we've seen in the previous history of Java, and that's been very good for Java as a platform. Just to sort of wrap things up, I want to talk a little bit about Java community, because this is a really big part of why Java has been such a success. Yes, it's great technology. Yes, it's been very popular in terms of scalability for big internet applications, and that's all very good. But the success of Java has been about more than just that. It's been about the community. So a couple of things to say about this. One is we had this conference, Java 1, started in 1996, ran until under Sun until 2009. Oracle then continued it for a couple more years. They co-located it with Oracle Open World. And 2018, it became Code 1. Then in 2022, it went back to being Java 1, went back to being Java 1 on its own in Las Vegas. And then this year, excuse me, this year we had the Java 1 at the Redwood Shores offices of Oracle. So that Java 1, if you've ever had the chance to go to that, it was a lot of fun. It was great to find out about all the technologies that people were working on. And I just put a couple of pictures here. One of all the badges I had from the various Java 1s that I went to. There's a picture of a much younger version of me there next to Duke. I think that was 2004. And even a picture there of Scott McNeely with Steve Jobs when they were making an announcement about Java on the Mac. The other thing about Java is there are a large number of Java user groups all over the world. As you can see, there's lots in Europe, there's a number in Asia, and there's quite a few in North, Central, and South America as well. So they're all over the world, covering different places. And these are great ways to meet up with fellow Java enthusiasts, to learn about new things that are happening in the Java world, share your experience, share your ideas, and so on. And so, yes, I thoroughly recommend that if there is a Java user group near you, then join it and see what's going on and find out about sharing your interests. The other thing is, obviously, there are lots of Java-based conferences. Like I say, I'm currently at one in Colorado, Dev to Next, being run by Venkat. I'm sure many people know Venkat. And there are lots of other ones I've listed here, like JFocus in Sweden, JFall in the Netherlands, Java Zone in Oslo, which happened a couple of weeks ago, Dev Nexus here in the US, which is happening in March, Devox, there's various versions of that. Belgium is happening next week, as some of you may be going to that. There's various other ones in like Greece and Morocco and yes, Riviera Dev in France, JavaLand in Germany. Lots of conferences to go to if you want to find out more information. And then we also have Java Champions. This is run by Oracle, and it's the idea of recognizing people outside of Oracle who help contribute to the success of Java as a platform. Again, it's that community thing. So we find people who have done a lot in terms of speaking, done a lot in terms of publishing articles, helping to form user groups, anything that is working on the idea of promoting Java as a platform. It's kind of like the Microsoft MVP program. And as you can see, there's over 400. I think because I put 403 there, I'm pretty sure it's more than that now because I've seen a couple more people who've been recognized as Java champions. So we're probably closer to 410 now. So with that, just to summarize our 30 years of Java, I think it's right to say that Java wasn't really radically different. It didn't include anything that hadn't been seen before. When I went through that sort of set of technologies in the prehistory, all of the things that we're familiar with were done by different platforms before. But it was bringing all those things together in a single platform at the right time. So hitting that sweet spot when browsers were very early on, and allowing people to add functionality and do things in the browser really was putting the platform there at the right time. It's also interesting to think that Java has been massively more successful not on the desktop. So even though that's what created its first sort of popularity, it was the reality of moving it to the server, which has led to its longevity in the last 30 years of Java. It has been very carefully nurtured by Sun and continues to be nurtured by Oracle. I have to give real credit to both Sun and Oracle in the way that they have made sure that Java develops and evolves in a very controlled way, but adding the features that developers want. We see things like JDK 8, where we added lambdas and streams, a more functional style of programming. More recently, things like pattern matching have been added to the platform. And it's adding those things in a way that doesn't break backwards compatibility, but does allow Java developers to be more productive and write more reliable code and things like that. Again, part of that success, I think, is because it's open standards and open source. There isn't one controlling entity that's behind it. And again, it is more than just a computing platform. It's an ecosystem and it is a community. And the thing that I'd leave you with is, where will Java be in another 30 years? I have no idea how Java will evolve, and I'm pretty certain I will not be working on Java in another 30 years because I'll be 90. So I'm pretty sure I'll follow how Java evolves, but I won't be doing too much work with it in 30 years' time. So with that, I'd like to say thank you very much.